Okay, today we are going to discuss the action potential. So now action potential is a very important topic as per the physiology concern. So first of all, action potential, there is of two types of action potential. One is going to be a fast action potential, another one is going to be a slow action potential. So this fast action potential, we know that is going to be mainly seen in the atria as well as the ventricle muscles and also the Purkinje fibers. So first of all, this action potential is consist of 5 phases. So this is important. So this is the graph which is drawn between the membrane potential as well as the time. So you can see there is nearly 5 phases, 0, 1, 2, 3, 4. So these phases are very important in the case of the fast action potential. So first of all, we're going to talk about the first phase. First phase is going to be the 0 phase. And in case of the fast response action potential, so the membrane potential should be taken as minus 90. So this is another important term. And another one is that phase 0 potential. You can see there is a rapid depolarization in the case of phase 0. So this phase from the membrane potential is going to start from that of the minus 90, so which is a very important for the fast response action potential, and it is going to start from that of the 0 seconds. So first the phase 0, there is a rapid depolarization. You can see the what you call the peak. So the peak is increased so much. Okay, this depolarization is caused because the sodium channels are going to get opened. So the sodium channels of this what is going to called the sodium channels of this phase 0 is opened. Okay, so that there is more sodium is going to come into the myocardium. The myocardial cells is going to get more amount of the sodium. So once the sodium level is going to reach us above the threshold level, so what is going to happen? Another important thing is that this increase the amount of the sodium level is going to further activate other sodium channels that is going to present in the myocardial cells. So there is a further increase in sodium going to cause a rapid depolarization. That is what we call the phase 0. So this is due to the this causes the phase 0. And if I talk about the phase 1, so there is, you can see after the depolarization. Okay, so after the depolarization, you can see there is a small repolarization is seen in this diagram. So you can see that there is a rapid repolarization. That too, repolarization is not complete repolarization. There is a partial repolarization only. So what happens, what makes this partial repolarization is that the sodium channels are going to get closed. Here there is an opening of sodium channel causes a rapid depolarization. Now there is no sodium is going to present. So what is going to happen? Sodium channels are going to close, as well as the potassium started to get out, move out of the cells. There is efflux of the potassium is seen. So which is going to causes this rapid repolarization. Okay, as well as there is also another important thing, there is a potassium current is also going to present when there is a depolarization. Now the potassium current is not also going to be present because there is no depolarization seen in this phase 1. So you can see that phase 1 is due to the closing of the sodium channels as well as efflux of the potassium. And we also talk about the second thing is going to call this second phase. The second phase is a plateau phase. You can see there is no increase or decrease. It's somewhat forming a straight line as such. So why? Means this is a sustained phase. The plateau phase, why it does happen? Because the action potential is in this depolarization. They are going to present in the sustained depolarization. Okay, so why this has happened? Because the calcium channels, the permeabilities of the calcium channels ion increases, so that more calcium is going to come in. But what does that means? The sodium, you can see that the calcium is going to come in a slower manner, but they're going to long last for a longer time. They're going to long last for longer time, so that is a prolonged opening will be there. So that the sodium, calcium is going to come slow by slow. So they are in the sustained manner. They are neither going to increase nor going to decrease. They are going to be in the sustained manner. At the same time, the potassium also going to be move out at the same time. You can see all the phases the potassium is moving out. So here also the potassium moves out. So the durations of this phase is going to lesser in atria when compared to that of ventricle, this plateau phase. And the third thing is that the phase 3. So what I mean by phase 3 is that there is a complete repolarization. You can see here this is a small repolarization, but here is a more repolarization is taking place. Why this repolarization is called as a finer repolarization? So what makes this finer repolarization is that, so here the calcium channel is opened. So because of this calcium, okay, so in phase 3 you can see there is a final repolarization. This is because of the closures of the calcium channels, as well as more potassium is going to move out of the myocardial cells. That causes a rapid repolarization. And at the same time, this is the last phase called as a fourth phase, and which is going to come back to that of the previous membrane potential. So you can see this is the fourth phase what you have here. Okay, the fourth phase is known as restorations of the membrane potential, because the membrane potential is going to come back to that of normal. And what makes this happen means there is a opening of the inward potassium. In all the phases you can see that there is a potassium is going to move out of the myocardial cells. But in this phase the potassium is going to come into that of the myocardial cells. So because of this potassium is going to come into that of the myocardial cells, the membrane potential is moved towards the equilibrium. Here minus 90 is the equilibrium for that of the fast response action potential. So now because of the influx of the potassium into the myocardial cells, the fourth phase is going to come back to that of the equilibrium membrane potential. So this finishes the fast response action potential. So you can see that there is of the 5 phases we will be having. And first phase is due to the sodium opening, and the zero phase is due to the sodium opening, as well as first phase is the sodium closed, and then second phase there is a calcium channel is going to get opened, and the third phase you can see that there is a closures of the calcium channels, and fourth phase is the opening of the inward potassium channels. That means potassium started to get inside this myocardial cells, that going to causes the restoration of the membrane potential. Okay, so next we are going to talk about the slow action potential. So in the case of the slow action potential, we know this is going to very well taking place only in the case of the AB nodal junction, as well as the ischemic heart as such. Okay, there is going to consist of the 3 important phases. They contain phase 0, phase 3 and phase 4. There is no phase 1, there is no phase 2. So they both are absent in the case of the slow action potential. So as well as there is another difference is that, so in the case of the slow action potential, we can't see the phase 4 as a restoration of a membrane potential, that which we saw in the case of the fast action potential. In the case of fast action potential, we saw the phase 4 is going to be the restoration of the membrane potential. But as in the case of the slow action potential, the fourth phase is not a restoration of the membrane potential, it is the slow depolarization potential. So first of all, we are going to talk about the phase 0. What makes this? But another one important thing here, in this case of the slow action potential, we are going to take the membrane potential as a minus 60 millivolt. In the case of fast action potential, we took as a minus 90 here. So this is also important. So now what is going to happen? The phase 0, you can see that there is a rapid depolarization, but the depolarization does not form like a steep. There is no more steep. You can see as in the case of the fast action potential, this is more steep. But here there is not that much steep. They're going to be a small. They're going to be somewhat. Peak as such. So this is what you call the depolarization. So the depolarization causes because of the calcium ions started to get influx. There is more calcium started to get inside the myocardial cells. They are started to get increases, and they are going to increases when when this line is going to reach as the minus 40 millivolt, they have started to get increases. And in the case of a phase 3, what is going to happen? This calcium channels which is present going to get closed. At the same time, potassium channels opened, potassium started to move out. And in the case of phase 4, there is a slow diastolic depolarization. What is going to happen? This is the earlier part, this is the later part. In the earlier part, you can see the potassium also going to get closed. So the potassium is closed, and you can see the calcium is open. So there will be slight increase in this wave. So this is the phase 4, phase 3 as well as phase 0. So this is all about fast action potential, slow action potential. This is going to taking place in the case of SA node, and this is taking place in the AB node. So this is all about this, and thank you.